Hello, my name is Paul Parkinson, and I'm going to walk you through the workshop on developing Helidon platform microservices using the Oracle Converged database, the ATP database, deployed on the OCI infrastructure. And so throughout this lab, you will be building up the infrastructure and microservices that are shown in this diagram here. And, and so by the end, there are a couple aspects here, such as streaming and spatial and monitoring, that are being added to the workshop currently. So they're not in what I will go over, but all of the rest of this architecture here, you will be able to set up easily with this workshop. So having said that, there is a lot of content in this workshop. And so to keep this instructional video under 2 hours, you will need to pause the video at times and conduct your work and then resume the video to continue. So this is the URL of the workshop. And the nice thing about this workshop is that you can come back to this environment that you're setting up in OCI and finish the workshop later if you like, or add on to the workshop to design whatever microservices or things you want to experiment with. And so it's nice, you can go to this URL, like I say, and pick up where you left off. So these are the different labs included in the workshop. And as I say, there's quite a bit of content. So it's unlikely that you will get past lab 4 in a 2-hour time frame. But you will have a lot accomplished within 2 hours. And so very quickly in lab 1, you will set up some basic OCI resources, the OKE, the Oracle Kubernetes cluster. You will set up 2 ATP database instances, and you will learn how to use the Cloud Shell. Another nice aspect of this workshop is the whole thing can be conducted within the Cloud Shell, within the browser. So the only thing you need to do this workshop is a browser, and yet you're achieving this full architecture shown here. Lab 2, you'll go ahead and very simply grab the source code from the microservices and deploy a simple front-end microservice, just to have one microservice deployed. So you'll have this front-end, simulating a mobile app deployed by the end of lab 2. After lab 3, you will have set up database connections, tables, and AQ messaging. So you will then have connectivity between your Kubernetes cluster here, shown in blue, and your databases shown in red. And we have a database, a PDB, for different services to follow the microservice model of decoupling in that way. And then you'll set up the propagation between the queues that's used for the messaging aspect of the workshop. Then after lab 3, you've set up basically all of the infrastructure on here as far as OCI, object storage, and things like that. And so, that will take you maybe half of the time of the workshop, half of the 2 hours. So within an hour or so, and everyone will go at a different pace there, depending. You'll have the setup, and then lab 4 will take you into a lot of the concepts. And you'll actually deploy this full microservice app, and you'll be able to go through the concepts. And what that's going to look like as far as the app itself is this page here. So after that, lab 2, you'll have this basic static front end. It won't do anything, but you'll be able to bring this up via the load balancer. And you'll be able to test connectivity from this microservice that's deployed in Kubernetes, test the database access from that to the ATP instances that you create. You'll then go, you'll set up your messaging, which is just a matter of pushing these buttons. And then the actual app is, you'll be able to start getting into that. And so this is what you see here as far as the application. You see different data types used, JSON for the orders, relational for the inventory. You'll see AQ transactional event-driven communication. So you will see that you can conduct work and send a message within the same local transaction. And that makes for exactly once delivery and guaranteed atomicity. You will see a basic saga, which is a data integrity pattern for multiple microservices, where all microservices use local transactions. There's no distributed transaction protocol, so that you can gain the advantages of microservices as far as scaling and things like that. And that's between the order and inventory service. We'll see event sourcing, which again is conducting work and sending a message describing that work. And you will see CQRS, which is command query responsibility separation, segregation, meaning we will insert orders. Which is a command using JDBC. But when we actually query for the details of the order, we will be doing that based upon events. And so there's a separation of the command and query APIs and thus the name. And so you get the idea. It's a basic online store called GrubDash, fictitious store, and you will be issuing orders and things like that. And then we'll also show off some concepts as far as how easy it is in Helidon to integrate with OCI and Kubernetes and the database in general. But it'll show some certain concepts as far as showing metrics, showing health and liveliness probes of Kubernetes working together with Helidon, so that you have reliability as far as automatic pod restarts and things like that, and tracing as well. And so that's what we'll have done. As I say, I will go up until lab 4 in this video, but I encourage you to continue on to do the other labs. Lab 5 is actually quite straightforward. What you will be doing is simply undeploying the original inventory service that you've deployed, which is a Helidon MP implementation, and then replacing that or swapping it with an implementation of the inventory service in a different language, such as Python. We also have JavaScript and Helidon SE. And so that's a quite simple lab to go through. And then the lab 6 is about scaling. We will put stress on the application such that it will demonstrate horizontal pod scaling in the Kubernetes layer, as well as scaling in the database layer. And then we have an Apex lab as far as lab 7. And I want to mention that we are continuously adding to this workshop. So any feedback in general that you have, anything you want to see added or things like that, please, feel free to contact us. We will definitely get back to you. And we have incorporated different aspects into this lab and are working on different aspects now based on customer feedback. So please do let us know. I believe there's even a note here as far as if you see issues, you can go ahead and submit this form and the workshop name, lab, steps, things like that. So even, issues or just, as I say, any kind of feedback, we'd be interested in that. And that link is right here in the workshop. So this is the URL to get to everything you need. And so let's hop in. We are going to first go ahead and sign up for an OCI account. So for this workshop, if you have an OCI account already, that's great. If not, you can go ahead and sign up for a free trial. And that will give you all of these resources are always free. And that is with the exception of OKE and OCIR, which you will get, I forget the dollar amount, but you'll get a certain amount of credits and up to 30 days. And so you can go ahead and use that. If you have a free trial already where you used all the credits or something like that, this workshop up to Lab 4 costs something like $2 actually, if you want to, you know, just continue. It only, you know, costs a couple dollars to run. If you're going to start doing things with scaling and load and things like that, it may cost more, but just so you know the different options. So go ahead and sign up for a free trial. I'm going to kind of make this a split screen for this workshop. I think that might be the easiest rather than jumping back and forth. I'm going to have on the left the documentation, and on the right the OCI console and the Cloud Shell that we're going to use to conduct the workshop. So just creating an account. And so once you've done that, that's a fairly quick process, probably take less than 5 minutes. As it says, just enter email, country that your region, things like that. And then go ahead and sign into your account. It will sign you in automatically after you do it, and you will be on a page such as this. And this is your OCI console page. So now we're all set with that. Again, you can click over here and to see where you are in the lab, look at the different labs in the workshop rather. So now that we've set up our account, let's go ahead and set up this infrastructure. And what we will do here is go ahead and launch the Cloud Shell. Let's start that first. So that's this icon up here in the OCI console. We'll just go ahead and click on that. And this is the first time using it, so it'll take a few minutes to initialize it. And while it's doing that, let's just take a little overview of all the things we're going to install here. So we're going to get the workshop source code, first of all. We're going to create a compartment in OCI, and then go ahead and create the Kubernetes cluster, the 2 ATP databases, the OCI registry for our Docker images, and the auth key for the login, and log into it from the Cloud Shell. We'll then go ahead and also access the Kubernetes cluster from the Cloud Shell. And then we'll install the Graal VM, JDK, Jaeger that we'll look at for tracing later, and the front-end load balancer to actually access our microservices application. So we see the Cloud Shell is ready here. Let's proceed to step 2. We will go ahead and just curl the source. So we'll go ahead and copy that command, run that. And once that's done, we'll just go ahead and cd into that directory. We'll move on to step 3, which is to create the OCI compartment and the OK cluster in that. So we'll go to this menu here, down to identity and compartments. We will then click create compartment. And you can really name this whatever you want. We're going to name it MS Data Workshop. And we can give whatever description we want here. And then just click create compartment. We'll go ahead and go into that compartment and go ahead and copy. I think maybe we could have done that from the last screen as well, but go ahead and copy the OCID for that compartment we just created. Now we'll go back to this Cloud Shell, and we can verify we're in the correct directory in case the Cloud Shell session will time out after something like 20 minutes. And so when the Cloud Shell will preserve all of your files, but you will come in with a new session. So if you have timed out, you know, that's why that instruction is there to verify you're in the workshop directory. And indeed we are. Then we're going to go ahead and run the command to set the compartment ID. So we'll go ahead and set compartment ID. We see that's in the directory, and then paste in that compartment OC ID that we just had from up here. And then we're going to add also the region ID. And so you can determine the region ID. One of the easiest ways is it's actually in the Cloud Shell. So it's right here. I'm using US Phoenix 1. You can go ahead and copy that. It's available in the console a number of places, but that's convenient. So we have the arguments, set compartment ID, the compartment OCID, and the region ID. Just go ahead and hit enter. And that's all. We've just stored the values. So now to create the Oci cluster, we'll go back into the OCI console here, and we're going to go down to Developer Services this time and Kubernetes Clusters. Make sure you are in the newly created compartment. So over here is the compartment list, and here is our compartment. I named my tenancy MS Data Workshop as well, misspelled, but just to point that out, that's the tenancy, and this is my compartment underneath. So, and then we'll go ahead and hit Create Cluster, and we'll choose to do a quick create and launch the workflow. And we'll go ahead and just name this MS Data Workshop cluster, and hit next. And then we'll go ahead and create cluster. So you can see it's extremely easy to create a Kubernetes cluster, and you can see all the resources underneath being created for you. It's, you know, you didn't need to do anything for this. We'll go ahead and close that. And this takes a variable amount, but it's generally definitely done within 5 to 10 minutes. So while we're waiting for that to provision, we won't waste time waiting. We'll go ahead and create databases at the same time. So all we have to do is go ahead and go into our Cloud Shell here and issue this command to create the ATP databases. Go ahead and hit enter. And at any time, of course, you can maximize the Cloud Shell here. So we can go ahead and maximize the Cloud Shell to get more real estate on our screen. And so just by running that script, we've now created 2 ATP data sources, the order DB and inventory DB data source. And we can confirm that this matches that output. So that, just like the OKE cluster, that's now provisioning behind the scenes. And we can proceed to create an OCI registry and auth key and log into it from the Cloud Shell. So now let's go back here. And we'll go to Developer Services, Container Registry this time. Developer Services, Container Registry. Let's go ahead and minimize our Cloud Shell so we can see that. And take note of the namespace. So here we see this namespace. You know, we'll have this type of value. And hit Create Repository. And then you can really put in anything here. So we're going to put in first name, last name, and MS Data Workshop. And we're going to go ahead and make this public just for convenience. We can set up keys to set it to be private, but you know, for convenience, we're just going to make this public and hit create. And now we can see that that has been created, okay? And then we're going to go into our Cloud Shell and run add OCIR info. Go down here and run that. And we're going to provide the namespace against this value here. And as the second argument, the repo name. And we gave that the name, I gave it my name / MS Data Workshop. And all of these script commands were saving the values into file. And so they're nice and preserved. They're saved into this working directory, as you can see here. And so, you know, it's nice we can preserve it. And we're going to use it later when we're building the microservices, et cetera. So now we'll go ahead and create auth tokens. And this will allow us to access the OCI repository to push our Docker images for our microservices and pull them, et cetera. So let's go ahead and click the settings and go to user settings. Hopefully you saw that, click the little icon there. And we're going to go down to auth tokens. And we're going to hit generate token. And we'll just call this MS Data Workshop token. Generate that token. And now this is very important because you will not see this token again. So let's go ahead and copy that. We'll just leave the screen open to be safe. And now we'll go into the Cloud Shell here and issue the Docker login command to log into OCIR. And we'll provide the username that you used to create the account, which is generally an email. And we'll provide that auth token that we just generated. And we need to make sure that you put the auth token in quotes. So quote, paste the name of the auth token, end quote. And we can see that login succeeded. Now let's go ahead and test it by doing a Docker images command. And we can see the repo is empty, but we can at least see, you know, access for Docker images. Then let's go ahead and access OKE from the Cloud Shell. So we'll use this command verify OKE and create the kube config. That's the config necessary to access the Kubernetes cluster. So we'll just go ahead and paste that command in. And you can see it's creating the directory and writing the config to it. And then as a test, we create the MS Data Workshop namespace, Kubernetes namespace, and we see that that was created successfully. So we now know that we have created the Kubernetes cluster and we're accessing it successfully and issuing commands against it. So the last thing we'll do in this first lab is go ahead and install GraalVM, Jaeger, and the front-end load balancer. So we'll just copy that command, paste it into the console, and this will go ahead and do all of those instructions for us. Now, while we're waiting for that, we can go ahead and move on to our second lab. So again, in our second lab, we're going to set the values for the workshop in the environment. We're going to build and push our first Docker images for the workshop. And then we're going to build and deploy and access that front-end UI microservice. So to set the values, we're simply going to run these commands to add and source properties in Bash. So we'll just wait until this install is complete as far as Graal and Jaeger.
Okay. And then we'll go ahead and paste this command. Okay, as easy as that. And then we'll go ahead and source our bash. And so again, this makes it convenient because whenever you open a shell, this will source all your properties. So again, if you want to leave and come back and start a new Cloud Shell session, all of your properties will be there. You won't have to source anything and build it up again at all. So it's convenient. Okay, so now let's try and run the build script in order to build all of these and push them to the repo, build all our microservices. Let's go ahead and run that. And as it says, this will take, there will be a lot of output here. As you can see, it's downloading and building everything. Now this will take a good 20 minutes to build and push all of these images since you're doing it for the first time. And in particular, the Python microservice takes a while to build and push. But again, this is building and pushing every single microservice in the workshop and doing it for the first time. So while you're waiting, in the background, if it's not provisioned already, ATP instances and the Kubernetes cluster will have been provisioned by now, as well as the load balancer. And during those 20 minutes, I'd encourage you to, just look through the console. For example, if you want to look at the databases that we created, you can go into this ATP area here and see those two that we created with the script. But in any case, you'll want to pause the video at this time and wait for that to happen and come back. But now that we have built them and deployed them, we'll proceed to the next step, which is to go ahead and check them in the console, check the containers that we just pushed. So we'll go again to Developer Services and to Container Registry. And we will see all of the microservices we just built and deployed. Okay. And so we're going to go ahead, as I said earlier, just as a convenience for making these public. You can, of course, make them private with keys, but we're going to make them, in the interest of time, just make them public. So we'll go through and select these resources, and under the actions, select these resources. And under the actions, change to public. Okay, we'll just do that for all of these. Okay. And now let's go ahead and build and deploy and then access this UI. So we'll go ahead and set the Jaeger address. We installed Jaeger earlier. Now this script is going to go ahead and set the address of the endpoint, the load balancer that was created for Jaeger. So we'll just go ahead and issue that command. And we'll go ahead and source the bash file. So now we have that in our environment. Let's go ahead and change directories into our front end. So under our main workshop directory here, we have our different services, and so we're looking at front end. Go ahead and build and push that. So even though we had built and pushed the front end, we are doing it again here to incorporate the Jaeger address that we had just set. So we went ahead and build and pushed that. And now we're going to go ahead and deploy it. So we'll just copy this command to deploy. And we see our location. This, the fact that the load balancer already exists is expected since we ran this previously, so that can be safely ignored. Now let's go ahead and check all the pods to verify our deployment. So we'll copy that command in. And we will see here that we have our Jaeger deployment for one thing, but our front-end web service. And it's in the process of creating the container now. So we can just issue that command again. And we verify that it's now running. It doesn't take long for it to run. And there is a pods shortcut command. So there are a number of different commands. If at any time you're interested in a command list or various commands, you can type MS Data Workshop. And this will show you all your deployments, pods, secrets, services, and finally at the end, some shortcut commands that are included in the workshop. So by doing that, we've essentially done this command as well to get services, but I'll reissue that and we can see the services there. And so we can see that for our front end, we have this load balancer and it's running at this address. So we can now go ahead and open a tab and access our front end service. So we see that's the IP and the port is 8080. Let's go back to our tab here. Or actually, maybe we'll open, yeah, we'll open it here. And now we see our first microservice has been deployed onto the Kubernetes cluster. And so this is just static right now. So you can look at things, but these buttons won't actually work because they're hitting the database and things like that. So that's what we will cover in the next lab, setting up connectivity. So let's do that. We've completed lab 1 and lab 2. Let's move on to lab 3. Again, we'll be creating the Kubernetes secrets that will store the information for our microservices in Kubernetes to connect to the ATP databases. And then we're going to verify that connectivity and set up all of our messaging and tables and queues and things like that. So let's go back to our Cloud Console here. And we're going to paste in this command to go into the ATP secrets setup directory. And then we're simply going to issue this command to create all. And so this is doing a number of things. The output will show you this. It's bringing down the wallet for the 2 databases, which has all this connection information files. And then it's translating them or creating from them the Kubernetes secret. That Kubernetes secret will then be referenced in the microservices deployment file in order to set up the environment for the microservice. And so again, we'll look into that a bit more, but basically you can set up the environment variables for your microservice by pulling that information from these secrets. So we've already done that, create all. Let's go ahead and issue that MS Data Workshop command again. And again, let's expand this console so we can see a bit more information. And so what we're really looking for here are these secrets. And so we see the general binding information, the information for connecting to our inventory and order database, And then we also see secrets for our credentials for the admin user for the inventory service and the inventory user, and likewise for the order admin and order user. So we have all our secrets created. If, you know, this is just a cleanup, we won't do a delete all, but if you need to clean up later, you can just issue that delete all command. Okay, let's go ahead and verify and understand this connectivity. So we're going to go ahead and look at this deployment YAML very quickly. We'll just cat the file. And what we see here is the volumes that are mounted for this deployment bring in the secrets that we just created, that we just looked at in that command. And from those, we can then set this, the environment variables for our container. So we have a container here, which is our admin service. And we're setting this environment as far as the user, the password, and the URL. And we're getting that from these secrets that we just created from the wallet that we downloaded with that script. And see, we're going to be replacing values as far as the PDV name and things like that. So it's very easy, you know, to get this information, to create a database and then get the information into your application. Then we can go ahead and look at the micro profile config properties file. So these microservices are built with Helidon MP, which is an implementation of the micro profile standard. And part of that standard is this micro profiles config properties file. So let's take a quick look at that. And what we see here is the setting of properties to access our database. And so you'll notice this is the same convention that was used to set our environment in the deployment descriptor. So we have this type, and then the name of the object, and then values to set on it. And so this properties file serves as basically a mapping. That environment will overwrite the values that are in this config properties file. And so we have the information to then inject a data source into the app. So again, the basic flow is to create a database. From that database wallet connection information, create a Kubernetes secret, reference that Kubernetes secret in our Kubernetes deployment for our microservice, and by referencing it, set up the environment, the environment properties or whatever you're going to use for your microservice. Set that up, and then our Helidon microprofile microservice is going to pick up that environment and inject a data source into our source, into our class. And so that's what you will see here. Oops. Copy this again. Okay, and then we'll see at the top of this file here, we will see the two data sources injected. And so this is all we had to have in our microservice was this inject name, and you can see this is the name we had before. And now we have a reference to an ATP data source, a database for a data source in our microservices app. So it's very nice, very decoupled, portable. You know, you can move around from different databases and things like that, or move the database itself around. Very handy. Now let's go ahead and deploy this. So let's go into the correct directory, and let's issue the deploy. So this is This is doing a number of things as well, as far as setting up propagation between our two databases. So we have message propagation between the two PDBs. And so this is giving us information as far as setting up a DB link and things like that. And this is just all done behind the scenes. You don't need to worry about it. Okay, so now, now that deploy was successful, let's go check the pods command to see if it's running. Okay, the pod is initializing. This initialization, is particularly for the first time, there are a number of things going on as far as, as I say, bringing those secrets in and, referencing all of this. So let's check on it again. And now we see it's running. It didn't take that long. We'll go ahead and go back to our, this is telling us where our front end is, but we still have that open. So we'll go back to our application. And no need to redeploy the front end, of course. That's part of microservices, is that you can deploy each service independently. So no need to redeploy the front end. And we'll click on this data sources tab, and then we'll click test data sources. And this is running against that, making a query against that admin microservice we just created. And so we see it's made a successful connection to the order in the inventory service. So as simple as that. We now have our Kubernetes talking to our ATP data source. And then this is just going into the setup for our tables, queues, message propagation, etc. So let's go ahead and click on the setup data and messaging tab. And very simply, we're going to go ahead and click each of these buttons in this setup so we can do these in discrete tasks. So first thing we'll do is create the users. So we're creating our, and that was very quickly done, our order user and our inventory user in the database. We're going to create our inventory table. So that was created. We're going to create our database links. And this is doing a number of things as far as pulling down information from object storage to create the links and things like that, but that was done very quickly. Now, then we'll go ahead and set up the table queues and the propagation between the two databases. And so this is doing a number of things now and verifying the whole setup. And so this can take a while because we're sending messages, we're checking the messages are propagated in both directions, things like that. And so if you want to check on the status as it's running, we can go ahead and copy this command, this log pod admin command, go back to our Cloud Shell here and paste it. And then we can tail the log for this admin service and see what it's doing. And so as I mentioned, you can see it has set everything, it's verified the DB links and all of the, it's created all of the queues and everything like that. Now it's publishing a number of messages of different types and priorities and things like that, just making sure this setup is complete. And then it's just doing a, like a sleep and then waiting to listen to the messages and things like that, so. Okay, so that took about 6 minutes. So if you want to pause the video here and wait for that to complete, and then we can continue from here. But everything you can kind of tell from the output that things were successful or not. And then this is just if you happen to have do any maintenance on your database or anything like that, you don't need to go through all of this again. You can just set up the tables and propagation. Again, that's all that's saying there. And with that, we are complete with lab 3. So now we have all of our infrastructure set up. That was a good, hour or so at least but we have all of the infrastructure that we discussed on the open page here. Let's take a look at that diagram again. At this point, we now have, we didn't set up monitoring or streaming, but we have every bit of infrastructure on this lower level here, suppose OCIR, object storage, our databases, propagation between the two databases, our OKE cluster, our mobile app, and our mobile app front end service and our admin service, and we've built and pushed all of these images. So we have a lot done, and we're all set up to move to Lab 4 to really start to look at some of these microservice data-centric concepts. So let's do that. So we will go ahead and deploy the other services, and then we'll go through the various, saga, et cetera, that I mentioned earlier as far as step 2, metrics, health, and tracing. So one thing this app will show is different aspects of the converged database. So a number of different data types, but we're really kind of showing 3 and actually particularly 2 in this. So we show the order is inserted in JSON format. Meanwhile, our inventory is a normal relational table that we issue JDBC SQL commands against, whereas the JSON, we're using the Oracle SOTA API. So we're just manipulating a JSON document. And then for delivery information, which we've added on in a later lab, we're using spatial information to show that. So we're just giving that sort of basic ER diagram for that. So now that we know what we're setting out to do, let's go ahead and go into the order directory. And then we'll go ahead and deploy our order service. Okay, so the order deployment pod is created, and the service that will front that microservice. And let's go ahead and do the same thing for our inventory service. We'll go into that directory and deploy. Okay, and then we'll do the same for our supplier service. The supplier service is just manipulating inventory. Okay, and then let's see the status of the deployments and see if our pods are running by running the pods command. Okay, so we see the supplier and inventory are still initializing. Let's just check again. You can pass -W and it will continuously listen for any changes. So you don't have to keep issuing the pods command. Okay, so we see all of our deployments are running successfully. Let's go to step 2. We will verify the order and inventory service. So again, we can go ahead and just run this services command as we did before for the front end in Jaeger. And we'll see all of our different services. Now, all of our different microservices have services that front them, Kubernetes services. All right, so now let's go back to our application. Everything is now fully enabled, so we can go into our transaction and start to test some scenarios here. And so let's go ahead and check the inventory for the sushi by clicking Get Inventory. And we can see that the inventory for the sushi is now at 0. So let's try to place an order for the sushi by hitting Place Order. And we do this in 2 steps. We place the order and then we click Show Order so we can see the different stages. So the initial stage of Place Order is that the status is pending, because we are pending the retrieval of the inventory by the inventory service to see if this order can actually be fulfilled. And so when we go to show order, because there was not enough inventory, remember the sushi inventory was at 0, we expect this order to actually fail. And that's what we see. It failed. Inventory order does not exist. And so what we're seeing here again is a saga between the order service and the inventory service. And the compensating activity of this saga for the inventory service is to restore the inventory back to the original state. And for the order service is to set the state to failed. And as in the normal case, it would go to successful, of course. And so that's what we see here. And this is a basic choreography saga, meaning that that saga is negotiated or worked out between the 2 services, as opposed to an orchestrator like LRA or a business process, where a devoted process would coordinate that saga between the participants. And I'll be adding a number of different LRA aspects to this workshop in the future. As I mentioned, I'm adding a number of different things, and that's one of them. Let's go ahead and do the success case. Let's go ahead and add inventory. So now we see that sushi inventory count is 1. Let's go ahead and place an order again. This is just, if you see this message, it's because I used the same order. And so we used order 66 already. So we need to use a new order number. So let's use 67 and place the order with that instead. We see it's initially in a pending state, and then when we show the order, it's in a successful state. Now, this not only shows the success outcome, but it also shows some of the concepts of this CQRS, as I mentioned earlier. So what we see is that we used a command to insert the order into the database when we did a place order. But for our show order, our query is not a SQL command. Our query for the information about this order is actually a combination of events that this order service has received. And so we did not have to do a query from the order service to the inventory service, or from the front end to the inventory service, because the order service was listening for events from the inventory service for a number of things. It may have been listening to a suggestive sales service. This is just an example. We don't have a suggestive sales service here, but this is a message that was received, and the order service was interested in it. So that's how this, we're showing a very, very basic kind of CQRS concept here as well. And with that, I believe you can read through, some more of the detail here, but we've gone through, the basic concept of this page. I do want to show you a bit of a diagram to further illustrate some of the concepts as far as the event-driven architecture that's going on here. So let's take a look at that. So this is a diagram of our app captured using a tool called Kiali. So Kiali runs off of Istio, which is a service mesh. And so the current version of this workshop, we don't go into that, but I'm just mentioning here this is where this diagram is from. I'm just using this diagram to describe some of the concepts in the application we just saw, as far as the saga and event sourcing, etc. So here we have our front end service. Again, this is Helidon MP. And these arrows indicate from the front end to the order service and the supplier service indicate sync REST calls, or gRPC if you happen to be using that. It is not messaging, in other words. And so the front end is calling the order service to place an order. In the order service, something unique is happening due to the fact that we are using advanced queuing, AQ, in the Oracle database. And that is the ability to have database work and message dispatches or receives in the same local transaction. And this is a very unique feature, and it's a perfect match for microservices and the concept of event sourcing. And so basically what happens in event sourcing is that you, again, any change that you make to data, you then send a message that describes that change, and any interested parties pick up that message. And so because XA and two-phase and these distributed locking patterns do not take advantage of a lot of the microservice, strengths. We need to use local transactions. And when you're using distributed locking in a microservice environment, you can't take advantage of a lot of these strengths as far as extreme scaling and things like that, because you have these locks distributed, and it will slow things down if you're dealing with a number of different network aspects and things like that. And so you may actually even see exceptions and failures in your application because of these locks being held. So that being the case, these local transactions that have the ability in the Oracle database to send messages and do work in the database atomically are a perfect fit for microservices, because you get the benefits of exactly once delivery. That's very valuable in this case. So in other words, if you did not have this feature, and on the sending end, if something failed, you might have the database write and a message not sent, or the message sent and the database not written. You'll need to rectify that in the system. And on the receiving end, if one of those two operations happened and the other didn't, you may have duplicate delivery of messages. And so your microservices will need to be idempotent and handle the same request multiple times. Now, best practices for microservices says that you should do that, right? Idempotent services, but that's much easier said than done. In particular, if you are migrating from an older system that wasn't written in such a way that it had to be idempotent and handle duplicate requests and things like that. So it's a very powerful feature. And what you see over here on the left is kind of how it looks in the code. It's a very unique thing where you have this JMS session, and from the JMS session, you can actually get a JDBC session. And that's how you're able to do these two actions, a message send or receive, or both, and a JDBC operation in the same local transaction. So back to our diagram, after having said that, we see the front end calling the order service, and the order service is doing just that. It's inserting the order in JSON format, and in the same local transaction, sending a place order message. Now, that's going to this, what's labeled as a pass-through cluster here. This represents the database, which is outside the Kubernetes cluster. It's putting a message on the queue there of place order, and the inventory service is interested in that message. So it dequeues that place order message, does three actions: dequeues that message, checks the inventory, and then in-queues a message stating whether that inventory exists or not. So 3 operations in the same local transaction, but without distributed XA locks or two-phase commit. So in the message about whether the inventory exists or not is then in turn dequeued by the order service, and the order service, compensates or completes the order as appropriate and returns that response to the front end. The supplier service is just manipulating it's acting as admin to manipulate the inventory levels. So that's its role. So again, you see here the event sourcing concept, and then the concept of CQRS. When we go to show the order, you can see here the front end is only contacting the order service, even though show order shows information about the inventory location and things like that. That's because the order service was listening to events about inventory information, not because the front end contacted inventory, and not because the order service contacted the inventories to get that information. It was all event-based. So I hope I've made that clear, if not redundant in my discussion. So now we've seen that concept. Let's go ahead and look at some of the other concepts, such as metrics. So in step 3, it asks us to go ahead and look at the source code for this order resource. Now we've put a number of annotations in this order resource to show off these different features. So if we go back to our Cloud Shell and we go ahead and look at this class. And we're looking at the place order method is of interest to us. And we see that here. So we see a number of annotations that we're going to go through here. And the first one that we're looking at is this timed and counted. So these are 2 types of metrics. And you can see all we had to do here was apply these annotations of timed and counted to our particular method. And Helidon will go ahead and then advertise these metrics for us. So if we go back to our application, and as it says, we click on tracing metrics and health, and then we click show metrics, we will see various built-in metrics as well as the metrics for our place order that we just looked at in the code. And these are all in Prometheus format by default. So we can use tools like Grafana to look at these in a more visualized, pleasing manner. But it's as easy as that, adding those annotations. So let's go ahead, now that we've looked at metrics, let's go ahead and look at the health aspects, verify health. So in the same way, we have a couple buttons here to show the health of our order service and the readiness. So both related to health. Liveness meaning the microservice is active, the process is running. Readiness indicating whether that service is actually ready to take requests. So it may be, the process may be up, but it may be initializing with database connections or whatever the case may be, so it's not ready yet. So we have these 2 ways of advertising. And so again, if we go ahead and look in the source, this time we're going to look at this liveness check in our order microservice. We can go ahead into our shell and just cat that file the way we did the other one. We see this very simple health check example here. And so we just implement the health check interface, and this shows liveness. And in this case, we're setting it. And as I say, usually this would be database connections or some criteria like that. But in this case, just to show, we have an internal boolean to indicate whether it's liveness or not. And that, by default is set to true, as we saw in the app. Everything is up and alive. Okay. And that's all we need to do as far as enabling the Helidon microservice to advertise its health. Now let's go ahead and look at the corresponding Kubernetes YAML. So we can do that by just catting it in our shell here. And what you will see is this Liveness Probe section here. And it's going to, this can be defined in any number of ways. And this is a standard Kubernetes construct. You know, you can check a file every so often. We're checking the Helidon microservice endpoint. And we're doing it every so often and things like that. You know, we'll start after a certain period of time to probe. And so, you know, the combination of these two basic steps allows Kubernetes to probe, depending on this, you know, as defined here in the deployment file we're looking at, our Helidon microservice, and the microservice is advertising. And so let's go back and look at a little demonstration of how this would work as far as restarting the container and reliability. So the basic thing we've put into the app is the ability for us to set liveness to false, to force it to advertise that it's not healthy. And the way we can kind of verify this is by looking at the last container startup time. And this will, of course, change if the container is restarted due to the fact that it's advertising that it's not healthy. So right now we see this time of 23:40:56. And what we will do is go ahead and set the liveness to false, okay? So we are now you know, setting that Boolean that I showed you in the code such that we will be advertising the fact that the microservice is in a failed state. This will result in the OKE probe coming around saying, okay, this Helidon order service is saying it is not healthy. So I'm going to go ahead and shut it down and start a new one. And so that's what is going on as I'm describing this now. And so we can go back and check. I haven't defined this to probe it so quickly and things like that, so it can take a few minutes. But let's go ahead and check. And we see connection refused. So it's in the process. It has already shut down the old pod with the microservice that was advertising it's unhealthy. And now it will start a new pod up. So if we check again, and then we check again and it's back up, and you can see it's a later time now. And that indicates that a new you know, container has started. And so now we'll go ahead and verify tracing. We'll notice tracing in a couple spots. So we have tracing in the front end and in the order service. And this is so you can see, you know, tracing between services, not just the information about tracing in one service. So we can look at both services. Let's go ahead and just look at our order service that we already looked at. So we'll pop back here and look at this order resource again. And so again, on that place order method, where we saw all the other information, we have this traced annotation. And that's all we need to do to get tracing about this microservice. Now, of course, we can go ahead and add even more information. And that's what we see down here, where we're adding tags and baggage to the span. So very quickly, if you're not familiar, open tracing and in the future open telemetry is the standard for tracing with microservices for in a cloud environment. And this may be the most widespread adopted kind of standard. So any product that you're using in the cloud will definitely be implementing or providing open tracing metrics. And so a very quick 1 minute lesson on open tracing. Open tracing, you have a trace, and a trace is made up of a number of spans. For example, and a span can constitute any number of things. A span would be, a call between processes, between, microservices. and a span can be arbitrary things within an application and things like that. So we can do that. Then there are tags and baggage. So a tag, I actually have it describe a little bit in comments in the code. These are annotations in order to query, filter, and comprehend a trace later. Whereas, and these are, sent async, all of this is sent async to a collector. And that's what we'll be looking at when we look at the traces in the Jaeger console. Tags are sent, whereas baggage is actually propagated along with the request. And so it's carries data across process boundaries, as I say here. So that's carried along with you. And so you see here, we have a saga ID and order ID, and we're propagating that along as baggage. And then you have also, the ability to add logs. And so that's your basic tracing. But if you didn't need this extra information, that's easy enough to add, but it's very easy to just put this @traced annotation on there. So let's go ahead and look at the actual tracing. So if we go back to our app and we click on show tracing, now we have, this was a kind of a convenience link built into the front end to bring us to the Jaeger UI. And so now we can see our services that we were tracing here, the front end in order service. And so let's go ahead and look at find traces for front end, okay? And then we'll go ahead and look at one of the longer traces. And when we look at that, we can see the requests that we had made to place an order from the front end to the order service. And you can continue to drill down, see any tags and baggage that has been added by the application, and get all information that you need. And so this is very valuable, of course, in microservices in general, but in particular with microservices that deal with data. And because you have these saga activities, and you're calling across all these processes, where maybe if you were in a monolith environment, it'd all be in one process. And so these tracing tools are very valuable. And so with that, we have really shown, we have gone through the major concepts of Lab 4. And so maybe let's go ahead and move on to Lab 5 and show the same service, same inventory service, but in different languages. So we'll show the polyglot nature that is supported by microservice environments. Okay, so this lab is fairly straightforward. We're going to undeploy the Java Helidon MP implementation of the inventory service that we've been looking at. So let's go back here. And go ahead and paste this command. We'll go into the inventory Helidon directory and go ahead and undeploy it. And then let's go ahead and deploy an alternate implementation. And so I won't go through all of 3 of these because I think you will get the concept. So we'll just pick out of complete random, let's pick the Python service. And we'll copy and paste that command to deploy the Python version of the inventory service. Okay, that's deploying. And then, we will just repeat the process that we did in Lab 4. So we can go ahead and issue the pod command just to make sure that the inventory service is running. Okay, and it's still initializing, so we'll just wait for that first. Okay, that's running. That starts pretty quickly. Go back to our app onto the transactional page. let's go ahead and place an order 68. Well, let's check the inventory again. And we see that the inventory is at 0 because we had reduced inventory from when we had the successful order. So we'll just go ahead and place a failed order. So we'll place this order 68. We see it's pending, and then we go to show the order, and we see it's failed as expected. We will add inventory and then place an order 69. We'll show that order and we'll see success, okay? And if you wanted to, you could go ahead, and one of the shortcut commands is log pod. These are, this is a shortcut command for Kubernetes logging, our kube control log command. And so we'll go ahead and log the inventory service. And you can see that it's logging the inventory, the Python inventory service. And you can see the related commands as far as it consuming the order, checking inventory, etc. So that's, very simple way. We're not doing any blue-green deployment or anything like this. We're at fancy. We're just undeploying and deploying a different implementation. And so you can do the same thing with Node.js or with the Helidon SE version of the inventory service. And in essence, that is, the essence of the lab number 5. So let's keep moving on to lab 6 to show off some of these scaling capabilities. So in lab 6, we'll be installing a K6, which is a load testing tool. And then we'll start the external load balancer for the order microservice, test the performance, and as I said earlier, we'll scale the application tier using horizontal pod auto scaling, and then we'll scale the database tier and demonstrate how performance has improved in those cases. So first thing we're going to do is go ahead and install this K6 tool. So let's copy that. Let's break out of our logging here. Paste that command. Okay, and let's start an external load balancer for our order service. Okay, and then we've done that, and then we will wait for the load balancer to be provisioned. So you will see this pending state. So just check back. This can take a few minutes. This is variable as far as how long the load balancer takes, but it's generally on the order of a few minutes to do that. So we'll just keep checking back. Okay, and it's up already. So we see this order service load balancer is ready. And then we will set this value. So let's paste that command, but change this value here to the value of this external order load balancer. So this value here. Okay. Now we'll go ahead and load, test, and scale the application tier. So we'll go into this. Oops. Okay. Go into this K6 directory and then note the request rate. So we're running stress against this. And again, all of these files are part of the workshop, obviously, so you can do different things as far as tweaking them for your own tests and, you know, whatever you want to do. Okay, so as it says, we'll note the request rate here, and then we'll scale to 2 service replicas. Okay. So we have our order Helidon, we're scaling to 2 replicas where we had, you know, 1 before. And now let's go and look at our pods. And you'll notice there were 2. As you may have noticed before, there was only 1 when we did that listing. So now we see 2 because we've scaled up. Let's go ahead and wait. Okay, that's running. Let's go ahead and execute the load test again. Again, here we saw this value, 2306.76 second. Okay, and then check that value. And then do the same thing when we scale to 3 replicas. Check the pods again. Okay, we see they're running. Not sure if I checked that last time, but we see they're all running state. So we'll go ahead and load test again. Now, in this case, we've been, you know, manually scaling this. We can also set up, and there's a simple demo for this, auto scalers. So it's a simple 1-line command to say if we, if we exceeded some threshold, in other words, if CPU increased over 50%, then scale to X number of replicas. So we're just doing it manually here, so you can see, you know, in discrete fashion, what's going on as far as, you know, as it says here, the median response time for the requests and the how the response time is degraded and the request rate has not improved significantly. So we see, we're looking at this from our latest run here. So now step 3, let's load test and scale the database tier. So now to scale the databases to OCPUs, we'll go into our console here. So we'll bring that down. And we'll go check out our databases here under ATP. And we see these are order and inventory databases. This is our inventory database. This is our order database. Okay, and then we see this scale up, scale down. Click on that and increase this to 2 and hit update. And then we wait until the scaling has completed. So the life cycle state is available. Scaling is in progress now, as we see. Okay, so this lab is fairly straightforward. We're going to undeploy the Java Helidon MP implementation of the inventory service that we've been looking at. So let's go back here. And go ahead and paste this command. We'll go into the inventory Helidon directory and go ahead and undeploy it. And then let's go ahead and deploy an alternate implementation. And so I won't go through all of 3 of these because I think you will get the concept. So we'll just pick out of complete random, let's pick the Python service. And we'll copy and paste that command to deploy the Python version of the inventory service. Okay, that's deploying. And then, we will just repeat the process that we did in lab 4. So we can go ahead and issue the pod command just to make sure that the inventory service is running. Okay, and it's still initializing, so we'll just wait for that first. Okay, that's running. That starts pretty quickly. Go back to our app onto the transactional page. Let's go ahead and place an order 68. Well, let's check the inventory again. And we see that the inventory is at 0 because we had reduced inventory from when we had the successful order. So we'll just go ahead and place a failed order. So we'll place this order 68. We see it's pending, and then we go to show the order, and we see it's failed as expected. We will add inventory and then place an order 69. We'll show that order and we'll see success, okay? And if you wanted to, you could go ahead and one of the shortcut commands is log pod. These are, this is a shortcut command for Kubernetes logging, our kube control log command. And so we'll go ahead and log the inventory service. And you can see that it's logging the inventory, the Python inventory service. And you can see the related commands as far as it consuming the order, checking inventory, etc. So that's, very simple way. We're not doing any blue-green deployment or anything like this. We're at fancy. We're just undeploying and deploying a different implementation. And so you can do the same thing with Node.js or with the Helidon SE version of the inventory service. And in essence, that is, the essence of the lab number 5. So let's keep moving on to lab 6 to show off some of these scaling capabilities. So in lab 6, we'll be installing a K6, which is a load testing tool. And then we'll start the external load balancer for the order microservice, test the performance. And as I said earlier, we'll scale the application tier using horizontal pod auto scaling. And then we'll scale the database tier and demonstrate how performance has improved in those cases. So first thing we're going to do is go ahead and install this K6 tool. So let's copy that. Let's break out of our logging here. Paste that command. Okay. And let's start an external load balancer for our order service. Okay, and then we've done that, and then we will wait for the load balancer to be provisioned. So you will see this pending state. So just check back. This can take a few minutes. This is variable as far as how long a load balancer takes, but it's generally on the order of a few minutes to do that. So we'll just keep checking back. Okay, and it's up already. So we see this order service load balancer is ready. And then we will set this value. So let's paste that command, but change this value here to the value of this external order load balancer. So this value here. Okay. Now we'll go ahead and load, test, and scale the application tier. So we'll go into this. Oops. Okay. Go into this K6 directory and then note the request rate. So we're running stress against this. And again, all of these files are part of the workshop, obviously, so you can do different things as far as tweaking them for your own tests and whatever you want to do. Okay, so as it says, we'll note the request rate here, and then we'll scale to 2 service replicas. Okay. So we have our order Helidon, we're scaling to 2 replicas where we had 1 before. And now let's go and look at our pods. And you'll notice there were 2. As you may have noticed before, there was only 1 when we did that listing. So now we see 2 because we've scaled up. Let's go ahead and wait. Okay, that's running. Let's go ahead and execute the load test again. Again, here we saw this value, 2306.76 second. Okay, and then check that value, and then do the same thing when we scale to 3 replicas. Check the pods again. Okay, we see they're running. Not sure if I checked that last time, but we see they're all running state. So we'll go ahead and load test again. Now, in this case, we've been, manually scaling this. We can also set up, and there's a simple demo for this, auto scalers. So it's a simple one-line command to say if we, if we exceeded some threshold, in other words, if CPU increased over 50%, then scale to X number of replicas. So we're just doing it manually here, so you can see, in discrete fashion, what's going on as far as, as it says here, the median response time for the requests and the how the response time is degraded and the request rate has not improved significantly. So we see, we're looking at this from our latest run here. So now step 3, let's load test and scale the database tier. So now to scale the databases to OCPUs, we'll go into our console here. So we'll bring that down. And we'll go check out our databases here under ATP. We see these are order and inventory databases. This is our inventory database. This is our order database. Okay, and then we see this scale up, scale down. Click on that and increase this to 2 and hit update. And then we wait until the scaling has completed. So the life cycle state is available. Okay, and that'll just take a couple minutes until the life cycle state is available. Then let's go ahead and execute the load test again. Maximize this. And indeed, you will see that the throughput has increased. So let's go ahead and scale down the application and database tiers. Go back to our console. And we'll just scale this back down to 1 as it was before. And likewise for the order service, just to clean up and bring things back to the original state. And so I will stop there. Again, you can go through the Apex app. It's fairly straightforward lab as far as showing more front end concepts and things like that. And of course, you have all of this in your Cloud Shell, in your account. You have this full infrastructure set up, and you can keep using it. Oh, excuse me, just going to do an ls of the workshop directory here. So you can see, all your different services, and you can tweak them, things like that. So again, I appreciate you taking time to do the workshop, or at least watch this video, and hopefully you will try it out. And if you have any questions, again, checking to this page here, if you just go on to the learning library and look for the microservices with converged database. I hope you will enjoy writing Helidon microservices against the Oracle database and OCI. And if you have any questions or comments, you can contact the forum on this page, or even contact me directly if you like. And I appreciate your time. Thank you very much.